Hi everybody. Today we will look at really important distribution in details, the normal distributions. In this video you will know about density curves, then normal distributions, and one of the most important rule, the 68 95 99.7 rule. What is a density curve? Yes, you know this is a histogram of a data set. If we connect the top of the bars of the histograms like this, we will get a curve. Let me get rid of these bars so you can see very clearly. This is a curve above the horizontal axis. There are some properties you should know about a density curve. You know this is x-axis and this is y-axis. Density curve is above the x-axis. Yes, a density curve is always on or above the horizontal axis. Next is about the area. Area under the curve and above the x-axis. Area under the curve is going to be 100% or 1.0. This is going to be true for any density curve. That entire area of the curve is 100%. It represents all of the data point. That is also very important property we use for solving problems. And finally, I can say a density curve describes the overall pattern of a distribution. I would like to explain this later in this video. Now, let me go to the normal distribution. Normal distribution is really important distribution in statistics. We will look at this distribution in details. The normal distribution is a continuous, bell-shaped, symmetric distribution like this. It has two parameters, mean, mu, and standard deviation, sigma. It is symmetric about mu. Now consider this example. X has normal distribution with mean 8 and standard deviation 3. Mean X has normal distribution with mean 8 and standard deviation 3. This first number always represent mean, which is mu. Second number always represent standard deviation, which is sigma. Let me draw this shape. Actually, this is density curve of normal distribution. It is bell-shaped and symmetric about mean, which is 8 in our case. So, let me draw this. To make it clear, I use several colors. So, this is mu, which is 8 in our case. So, you know each numbers in this side on this line greater than 8 and in this side less than 8. Now I'll show you what the empirical rule is. The empirical rule is also known as the 68 95 99.7 rule.
68% of the observations fall within sigma of the mean mu. That is the amount of data you find on normal distribution between one standard deviation either side of the mean. 68% of the data will fall in the yellow area in this diagram. Similarly, 95% of the observation fall within 2 sigma of the mean mu. That is the amount of data you find on normal distribution between 2 standard deviations either side of the mean. 95% of the data will fall in the yellow and light red area. Finally, 99.7%. 99.7% of the data will fall in the colored area in light blue, light red and yellow areas. Now let me explain this example. A research was performed on the IQ scores of the employees of a private firm. The scores are noted to be in normal distribution. The mean of the distribution be 100 and the standard deviation be 15. Estimate the percentage of the scores that fall between 70 and 130. Okay, let me take X as a scores, IQ scores, then X has normal distribution and 100, the mean is 100 and standard deviation is 15. So X has normal with mean 100 and 15. So this should be in bell shape because a normal distribution and symmetric about mean. In our case, it is 100. Right. Now, read the problem again. Estimate the percentage of the scores that fall between 70 and 130. Okay, 130 is greater than 100. So, it should be over here somewhere. So, we can get this. It is a 130 and 70 is less than 100. It should be somewhere over here. So, they are asking percentage, again percentage in between 70 and 130. That means the area under the curve and in between 70 to 130. So this is the area they are asking. We can use the empirical rule. First, I will check one standard deviation. It means we know our mean is mu plus sigma. Mu plus sigma is the one standard deviation. So it is 115. That means it is not the answer. We need 130. Now I add 2 times 15 to the 100. So then it is 130. Yes. We have one number we were looking for, which is 130. So you can keep this. And this means we use 2 standard deviation, mu plus 2 sigma. Therefore, we can check the lower number using the same 100 minus 2 sigma, which is 2 times 15. This equals 70. Yes, we did. So we do have both numbers we were looking for, 130 and 70. Now go back to the empirical rule. This 68, 95, 99.7. 68 mean sigma, 95 mean 2 sigma, 99.7 mean 3 sigma. So we can write probability, that is the percentage, in between 70 x 130 equal the percentage. Therefore, we will write this is as a percentage 95 according to empirical rule. So this is our answer. Now let me explain this example. A machine fills 212 ounce rice bags. Not all bags weigh exactly 1212 ounces. The weight of the rice placed is normally distributed with a mean of 200 ounces and with a standard deviation of 10 ounces. If you purchase a bag filled by this dispenser, what is the probability it has more than 210 ounces? Let's start at first one. First, write down the information we have. I take X as a weight of a rice bag. Then X has normal distribution. Mean 200. And standard deviation 10. We will draw the density curve for this problem. It is normal. So this is the density curve, which is bell shape, and symmetric about mean, which is 200 in our case. Then they are asking more than 210 ounces. So 210 is greater than 200. Therefore, it should be somewhere over here. So I will take this point as a 210. Then probability more than 210 mean the area under the curve and greater than 210, which is the area in green color. How do we use empirical rule to find this green area? Okay, first I will check mu plus sigma, which is one standard deviation. So mu equal 200 and sigma equal 10. Therefore, this is 200 plus 10 equal 210. Yes, that is the number we were looking for, 210. So it means this is the number of one standard deviation, mu plus sigma. Therefore, I will find the mu minus sigma, which is 200 minus 10 equal 190. Okay. 190 is less than 200. Therefore, it should be somewhere over here. So I say this is the 190. So by the empirical rule, we know the area in between 190 and 210. By the empirical rule, this area has 68% data of all observations. Therefore, green color areas at the left hand side plus right hand side has 32% data of all observations. Because we know whole area under the curve is 1 or 100%. Therefore, we can find the area we have here in green color 100 minus 68, that equal 32. But we know this is symmetric distribution, therefore this area at the left hand side area should be 16% and the right hand side green area should be 16%. 16 plus 16 equal 32. The areas must be the same. Therefore, probability it has more than 200 ounces mean probability is greater than 210 equal 16%. In main, you can write down this equals 16 divided by 100 equal 4 divided by 25. That is the answer for the part 1. Second one is asking what is the probability it takes less than 170 ounces. Again, let me draw the density curve. Mean equal 200. So 170 less than 200. Therefore, it should be somewhere over here. They are asking less than 170 ounces mean under the curve and less than 170 in this area. This area gives the probability x less than 170. Okay. How do we find this area? Using empirical rule. First, find the mu minus sigma, which is 190. Then, mu minus 2 sigma equal 180. 180. Still, we don't have 170. Therefore, find the mu minus 3 sigma. It is 200 minus 3 times sigma, which is 10 equal 170. That is a number we were looking for. Yes, we do have 170. Therefore, we know this is the number within 3 standard deviation. So, I calculate the mu plus 3 sigma equal 230. Okay, 230 should be somewhere over here. So this is the 230. By the empirical rule, this middle area is 99.7% because this is the area within 3 standard deviation. Therefore, we can find the green colored areas 100 minus 99.7 equal 0.3. So, one side of the area is 0.3 divided by 2, which is 0.15. Now answer for the number 2, probability x less than 170 equal 0.15%, which is very small probability. Next question, what is the probability it takes between 180 and 200 ounces? So this is the density curve of this problem. This is the mean 200. So they are asking between 180 and 200. So 180 should be over here. 180 and 200 is here. So probability between 180 and 200 mean the area under the curve in between 180 to 200. So this is the area we are looking for. Now we know mu minus 2 sigma is 180. It means this blue color area is half of the 2 standard deviation. Therefore, this area should be 95 divided by 2 because 2 standard deviation is 95% according to the empirical rule. So this answer is 47.5%. Now answer can be written probability x greater than or equal 180 and less than or equal 200 equal 47.5%. Fourth one, what is the probability it takes between 180 and 190 ounces? Density curve is this and mean is 200. It is asking 180 and 190. So 190 should be over here and 180 I take at this point. So mu minus sigma equal 190 and mu minus 2 sigma equal 180. Therefore, we know mu minus sigma is the 1 standard deviation. Therefore, this blue colored area should be the half of the 1 standard deviation. Therefore, this equal 68% divided by 2. This equal 34%. Alright. So next, mu minus 2 sigma. Mu minus 2 sigma is the 2 standard deviation. So it goes to 1 from 180 to 200. The area with green lines you see. So this is the area within 2 standard deviation. Actually half of the area within 2 standard deviation. Therefore this should be 95 divided by 2% is equal 47.5. Alright, we know these two areas. We are looking for the area, but we need the area between 180 190. This area. So, how do we find that area? We know the area from 180 to 200 is 47.5 and area 190 to 200 is 34. Therefore 47.5 minus 34 equal 13.5. That is the area or probability between 180 and 190 ounces. Last one, what is the probability it takes between 180 and 190 ounces? I leave this problem as a homework. Thank you for watching this video.